Alright, back with another quick one. This is going to be graphing trigonometric functions. But you can see the question that we got here has got a fair few transformations. So that's where it's going to get interesting. So this graph here is clearly a sine graph. You can see it says sine right there. So we know that it's some sort of transformation of the graph y equals sine x. And it's just got a bunch of transformations done to it to get it into this form here. So just by inspection, looking at the graph, we can find out a couple of things. We know that amplitude's 2, we know that it's been moved down square root 3, and it's got a period of pi, because the 2 here, the 2, if you expand these brackets, the 2 will move next to the x, and then that'll give us a period of pi, because 2 pi over n, and then our n-axis 2, and so then our period will be pi. And then it's moved across it's moved to the right, so in the positive direction of the x-axis, pi over 3. So you can write these out, and I will write them out, but the method that I'm about to use, you don't even need to know any of that information. Actually, yeah, you maybe might want to know a bit of it, but you really don't need to know much of the information to be able to use this technique that I only found out maybe like a couple of weeks ago. That I just kind of thought of. I'm like, that might come across as pretty useful. So yeah, we'll go over some of the properties that this thing has right now. So we can see the amplitude's 2, but that, I guess that doesn't actually matter. We just want to find its maximum and minimum values, really. So we know that the max value of this is going to be equal to negative square root 3 plus 2, and the minimum value is going to be equal to negative square root 3 minus 2. And square root 3, I want to say that is around 1.7 from memory. I think that's around 1.7. So therefore, our max value will be above the x-axis, because obviously 2 minus 1.7 is still going to be like 0.3 or something. So it will be above the x-axis, but obviously our minimum value will be well below the x-axis. Forgot to mention, we're just going to graph this line for x is an element of 0 to 2 pi. And before, as I said, our period. So I know period's equal to 2 pi over n, and our n is going to be 2, so that's going to be equal to just pi. So our period's pi, so we're going to get 2 full rotations within this domain here. And then I think that's all we really need to know for now. Yeah, that's all we're going to need to know for now. I'll just write this up here a bit small. So P is equal to pi, and that's really all we need to know for the moment. That is really all we need to know for the moment. So we know that this graph here, as I said before, is a translation of y equals sine x. So we're going to need to know what y equals sine x looks like. And we're going to draw it for 2 rotations, because there are 2 rotations in this graph here. It'll make things easier later. This may be the worst graph drawn you've ever seen, but all we want to know is the key points. So you know, a sine graph starts at the 0, 0 here. It looks something like this. That'd be 1 rotation, and that'd be 2 rotations. So we know that this spot here is pi, this spot here is 2 pi, 3 pi, and 4 pi. That x-axis is really long. I'll just go to there. This is going to get really messy. The method that I'm about to use, it's really exact. So you're likely, if you do the thing right, you're always going to get the correct answer. It's pretty consistent.
but the one flaw is that, especially with a graph like this, it's relatively slow. Like, that's really not an advantage. I get that's no advantage of it being slow. It's just that it's pretty accurate. So that's what this method kind of helps with accuracy. If it's like a smaller graph, you will probably not even need to use this method. You probably just graph it, especially if there's no like horizontal translations. They're usually pretty simple. We know that this max here is going to be pi on 2, and this is going to be the one down here is going to be 3 pi on 2. This will be I don't even know if this is right. That'll be 5 pi on 2, and down here that'll be 6 pi on 2. 7 pi on 2. Actually, I really hope that is right, because I don't even know, to be honest. And our minimum point is -1, and our max point is just 1. So we've got a bunch of common points, and then by finding the translations applied to this y equals sine x graph, this thing's just going to shrink a bit. It'll move around a bit, and that's as easy as it gets. So yeah, that's going to be our next step, is finding the translations. Or actually, first we'll find the endpoints of this graph. That'll also help us out. So I'm not going to do that first. I'm going to do our translations first. So I'm just going to have to simplify this one here. So that's going to be y plus square root 3 is equal to 2. So you just kind of want to bring all the terms you can bring over to the left-hand side where the y is, bring them over to the left-hand side. And we've got 2x minus pi on 3. And then we can still further simplify this. Y square root 3 over 2 is equal to sine 2x minus pi over 3. That is sort of pretty much as simple as it gets. Yeah, that's pretty much a fully simplified. I'm just going to put more brackets around there. That's pretty much as simplified as it gets. And knowing just your basic transformations, you're going to get y is equal to y prime. I'm not sure if you're going to call it y prime, but that's just what I'm going to call it. And then you get x is equal to 2x prime minus. And then from here, you want to pretty much get the y prime and the x prime by themselves to find the translations that have been applied to the graph. So you get 2y. This is a long simplification here. And you get x over 2. Well, I hope I'm actually doing it right, because I don't want to make a mistake. I don't even know the answer to this thing, actually. I just kind of grabbed the question and hope for the best. But using this method, it'll be a good tester. Is it really that accurate? Hopefully it is. Y prime is equal to 2y. Right. And then x prime, whatever that was, x prime is equal to x over 2 minus pi on 3. Alright, so I'm just going to tell you the transformations that have been applied here. We got it's moved in the negative direction of the y-axis, pi over 3 units. We got a dilation of factor 2 from the x-axis. Then on this x side, we know that it's a factor of 1 over 2 from the y-axis. I really hope that's right. Yep, 1 over 2 from the y-axis. Yeah, that looks alright. And then we moved, almost stuffed it up there. And then we moved pi over 3 units in the positive direction of the x-axis. So we can better write that as from our y equals sine x graph, xy, we get is obviously equal to y prime. Oh my god. Alright, hopefully we're not making too many mistakes like that. Is equal to x prime, y prime, and then we know what these are equal to. So we get x and y. Graph 2, we got x over 2 plus pi over 3. And then we got, a bracket there. And then we got 2y minus that. And that is it there. That's our transformations that we're going to need to apply. So pretty much the method includes, see this point up here? I'm actually sure if that, I'm not even sure if that's showing. So I'm going to use a quick little highlighter. This point here, which is 1 pi over 2, that's our first maximum point. We then put pi over 2 and 1, which is our x and y values, into here, into our transformations, and then it'll punch out a new value, and that'll be our spot on our new graph. And you pretty much do that with your first max point, this, with your first max point, your x-intercept, min point, and your next x-intercept there. That's one rotation, but as I noticed, this thing has 2 rotations within the domain. So then you got to go a second time, which is it's long. Like if there was only one rotation, it'd be pretty quick. But looking at this could take not sure how long this video is going to go for, because this could take a really long time. Yeah, get me concerned. But our first step, I'm not sure where we're going to end up drawing it, but what we're going to quickly find, this is pretty much just our main. This is what you need to take note of. This is what we've found out, and that's pretty much the method right there. Any point on this graph, we'll graph to this in the new graph. So but first we're going to find our endpoints, so we know we're just going to insert x equals 0 and x equals pi over 2 into our just crazy expanded equation here, because that's almost easier at this point. And then that should give us our endpoints. So we'll just do that now. And with a graph like this, because I just forgot what the circumstance was where there's some sort of circumstance where you don't get the same starting and ending values, but we know that the starting point and the end point for graphs like these are going to be exactly the same. I forgot where there is some sort of exception. I think it's when it pretended it was like 0 to like, I don't know, 7 pi on 8 or something. Yeah, if it was 0 to like 7 pi on 8 or something like that, or 8 pi on 7, where it just wasn't a full rotation, you'd get a different endpoint. But when it's like kind of 0 to 2 pi, that's just like kind of full rotations, and you get the same starting and endpoint. I'm not even sure what the real math behind that one is, but it's just how it works. See, in this sine graph, it starts and ends at the same point. Yeah, it's just pretty much start and ends at the same point, unless you get some weird domain. Anyways, we'll plug this one in. So we're just going to plug in 0, because that's going to be easy to calculate. So it'll be 2 sine 2 times the x is 0, so we're just going to get negative pi on 3 minus square root of 3. And then y is equal to 2 what am I doing? Thinking sine negative 2 pi on 3 minus square root of 3. And then this will be simplified to y, 2 times pi over 3, that'll be negative square root 3 on 2. Yeah, I think that's right. Minus square root 3. Oh, it'll be negative, sorry. Negative square root 3 over 2, because it'll be in the lower quadrants there. Therefore, we get negative square root 3 minus square root 3, and therefore y is equal to negative 2 square root 3. Hope that's right. I will actually check the answer. Oh, if the video is uploaded, the answer's right. We'll put it that way. So therefore, we know our starting point is 0, negative 2 pi 3, to give us around, I'm just trying to think of what that is. That'll just be 1.7 plus 1.7, so it'll be around negative 3.4. When, yeah, be something like that. And then our ending point's going to be the same, which will be at 2 pi. So now though 2 pi, that's somewhere else. Scroll down just a bit now. No, I won't. Not yet. I'm just going to write this, trying to squish this down here. 2 pi, which is our end point, will also be at that very point. And now the next part comes the longest part, but also the last part before you can literally just straight up graph it. It's inserting all these points. So we're going to need to insert pi over 2, pi, 3 pi over 2, 2 pi, 5 pi and 2, 3 pi, 7 pi and 2. So that's what, 6 values, 7 values? Yeah, I think it's like 7 values. But after my first rotation, I'm going to see if I can find a pattern, like with the x-intercepts or with the maximum points. I'm going to try and find a pattern so then I can just maybe just chuck something on the numerator and call it a day. So, but we'll just have to see if we come across that. So our first value here that we're going to insert into this transformation is going to be 1. It's going to be pi over 2, and that's when our y value is 1. I'm not sure if I want to write it up here. Actually, no, I will. I'm just going to see how much I can fit on this page. And that will map to, it's the worst looking arrow I've ever seen. This one's going to map to x over 2. So we're going to have pi over 2 divided by 2, which is going to end up being, it's going to end up being pi. But I'll just write it out. Ooh. Actually, I don't want to make a mistake. So, but who cares about making mistakes? Pi over 2 divided by 2. What am I doing? What am I actually doing? Pi over 2 divided by 2, which is, I don't know what the hell is that. Why can't I think of the answer to this? Pi over 2 divided by, it would just be times by 1 over 2. So it is just going to be pi over 4. Pi times 1 over 2. That's pretty much what it is. And then plus pi on 3. And then our y value is just 2 minus square root 3. So that'll give us this is our first maximum point on the graph. But we can simplify this x value hefty. So this will give us pi over 4 plus pi over 3. So for some reason, it's a ring and a bell that that's going to be 7 pi on 12. I'm going to have to quickly check that though. Let me think. Pi over 4 plus pi over 3. Times that by 3. Times that by 4. Yep, I reckon that's it. I hope it's it anyways. So that's one of our first maximum points. And then we're just going to insert pi into our next one. So pi 0. This is going to give us pi on 2 plus pi on 3. I don't know what happened with the other one, why I couldn't figure out what pi over 2 divided by 2, or It's still confusing. No, it's still confusing me just thinking about it. I don't know why. And then we'll have the negative square root 3. This will be simplified to times by 3. So you have maybe 6 on the bottom and 5. So 5 times 6 and then negative square root 3. I really hope I'm combining these fractions alright. I'm just thinking times by 2 times by 3. Yeah, that should do. Our next point, 3 pi and 2. Now this is where we might be able to find some sort of pattern. 3 pi and 2 negative 1. But yeah, as you can see, this will give us our minimum point, our maximum point here, which was negative 2 minus square root 3, which is our maximum here, which is 2 minus square root 3. So we know we at least got that point right. Don't know about the others though, I can tell you that much. And then we got 3 pi on 4. Now that we've figured out what we're doing with this. Yeah, I really hope that's right. If it isn't right, I'm not going to be too happy. And then negative 1, this is our minimum point, so we already kind of know that it's going to be negative 2 minus 3, but this translation method just confirms it. And this will end up being another big kind of value on the top here. So times this by 9. I want to say that's 13 pi over 12. I really hope it is. Let me just have another quick think. Yeah, that'll do. I'm not sure how long this video is going to end up being, but we got 3 points, so we got 4 points. 5 points actually, so we know our pi and 2 value is going to end up being the same as this one here. Well, obviously never mind. It's going to be the same y value, but it's not going to be the same as the others. Alrighty, now we've got the next value, which is 2 pi. I feel like there might actually be a faster way to, well, there obviously is a faster way to graph the entire thing, like the finding x-intercepts. But this way, I just found it to be really accurate. I don't know why I find it so accurate. So you insert that 2 pi. This is going to be concerned. Oh no, it's going to be pi plus. That's actually not too bad then. And then 0, so it'll just be negative. And this will give you 4 pi on 3 minus square root 3. So, oh no, I've just done that on the bottom of the page. I'm actually just going to quickly do this in different. Actually, I'll scroll down and you'll be able to see what I've done. I've pretty much just applied this pi over 2 0 into the transformation. I completely forgot that my camera actually blocks that. But you'll see that in a second. So we got 1 point. No. We're good. I thought it was erased, which is all I did. We got 1 point, 2 points, 3 points, 4 points. I'm starting to think this method isn't so godly. First, such a ridiculous question. But yeah, so we got 1, 2, 3, 4 points, 5 points, 6 points, and in total we want 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points, and I think I said we got like 6 so far. So we're just going to get another 3 points. So as you can see, with this 2 pi 0, I've just pretty much just subbed that into the I'm not sure if you can see this cursor. Sub that into just the transformations, and it's pushed out that for us. I'm not sure if I'm going to rewrite the transformation so I remember. But anyway, we'll move on to the next point, which is
5 pi and 2, 1. On to 1. I believe I kind of remember the transformation. Oh no, it'll still, as it's covering it, it'll still kind of be there. And then, yeah, I'm just going to plug this into the transformation. So 5 pi on 2, that'll give us 5 pi on 4 plus pi on 3. And the 1 will give us 2 minus, and this is another maximum point. I think that we only really get 2 maximum points in this entire graph, which is a sad thing, so we don't really have time to find a pattern, I guess. I can't really be bothered because I'm probably going to stuff it up anyways. And that'll give us it's going to give us another larger value. 15. I think that's like 19 pi on 12 or something like that. Yeah, that looks about. So that's equals maybe our 7th point. We just got 2 more points to go. So now we're going to get this pi on 3 and plug it into our transformation. Yeah, pi on 3 is 0. So, oh sorry, 3 pi, 0. Which would be 3 pi on 2. Because I can't remember the transformation now. And plus pi on 3. And then the 0 will give us negative square root 3. Which will make, this is 6, so 9 plus, I think that's like 11. Does not look 11 pi on 6, that's almost 2 pi. We're getting close. And then negative. Alright, then we've got our last value to plug in. 7 pi on 2, negative 1. Seven pi on 2, negative 1. Which gives us 7 pi on 4 plus square root 3 and negative 2 minus square root 3, which will give us 12 over, I'm getting something wrong here, I think 21 I've done something wrong. Why am I getting this wrong? I think it's wrong. I'm going to times this by 3, so you're going to get 21 pi and then plus 4 pi. I don't know what I've done wrong. Couldn't tell you what I've done wrong. That is no good. Trying to find my stuff up. I've just done something wrong completely. 7.2 except for 2, 7, 4. 7 times 3 is definitely 21. I'm getting something like this. I'm getting, that's what it is. I just figured it out. Alright, this here, see how we end up getting 25 pi over 12, and then what? Negative negative 2 minus square root 3. This is a good case. At least we got this case, which is another learning thing. See how this is clearly outside our domain. This is outside of 2 pi, which is out of domain. That's because it's been shifted to the right too much. I've taken this point here, 7 pi on 2. It's been shifted outside our domain. It's been shifted. Therefore, I already know what we're going to have to do. We have to take another value in here. We have to take this value here, which is pi over 2, negative 1. The reason that we have to take this value, I don't actually know why. It's been shifted to the right too much. Shifted to the right to the point where we have a point outside our domain. So we need to nigger on the right hand side. We have a point that's moved outside the domain. So we need to bring one from that was originally just on the other side. Yeah, I'm not even trying to explain it, but when you're shifting left and right, sometimes this translation method may not be the easiest, but you also come across it with the other method with your intercepts and stuff. But because this graph's been shifted to a certain extent, certain points will move in and out of your domain, and then you need to bring in sort of unexpected values. So at least we know that now. So we can cross this out and go, look, it's outside the domain. So now we've got to do our last value, which is negative pi on 2, negative 1, and we'll insert that. So then that'll give us negative pi on 4 plus pi on 3. And that'll give us negative 2 minus square root 3. I hope this ends up alright. Oh yeah, no, it's just kind of a frame. Okay, I'll pick that up. Let's go down one more. And then we're good to graph it. This is the longest method ever, but with a shorter question, trust me, it's accurate. And then we get 3 pi. So I think that's just like pi over 12. Yeah, because you get, yeah. I'm just going to say it's pi over 12. Hope it is. I will end up checking this before it's uploaded just to make sure. Because sometimes I've just chucked up a video and haven't even looked over it. Yeah, alright, so now we're actually ready to graph. Whoa, after all that time, we're ready to graph. Right, don't play waste a lot of time. We've got an insane amount of points that we need to know, but we're going to want to know the shape first. We can draw the shape and then just chuck in the intercepts in a sec. Is it not the straightest line I've drawn? Oh. No, there's that. I'm just going to have one more attempt and I'm just going to have to sit with it. That looks like that's our straight line. X. Oh yeah, I think on this graph up here, I didn't even put X and Y on this graph up here. X and Y. Otherwise, you don't even know if it's a Cartesian plane. X and Y. So we've got our endpoints. First, we'll just write in our maximum, minimum points, and our center where the graph's going to start. So we're going to call this negative square root 3. I'm just going to say it's around there as well. So we've got negative square root 3 minus 2, and then negative square root 3 plus 2, and there's just kind of an imaginary dotted line across here. Some points in the graph will connect with it though. And then we've got our first point here, which will sit around here, because we know that this value here is around a negative 3.7, and this is around negative 3.4, so it's like it would be just below it. And then the next thing to determine is whether the graph starts going like this or whether it comes from below
and starts going like that. That's the next thing to determine, and we'll be able to determine that by our maximum and minimum points, which one like pulls closest. So our first maximum point is at 7 pi over 12. That looks too far, a bit too far. But then I remember we actually pulled this one here. We pulled this one here, the pi over 2 negative 1. So I assume that's going to be the closest. So this is pi over 12. I think that's our shortest value. Yeah, that's definitely our lowest value. So we know that our first minimum point is going to be here, because there's no point, obviously the graph doesn't look like this, doesn't go over there and come back. So our first minimum point is before our first maximum point. So we know the graph some point here, and then then we've got our next maximum point, which is there. So we know this graph has 2 maxes and 2 minimums. So we can honestly just draw those in. Let that be our next one, and then we know it'll hit somewhere down here again, hit somewhere up here, and then before coming back to around here. So I'm just going to quickly try and draw this one in. We know the graph is, that hurt me. The graph is going to look something like this. Oh my god, that is some sine graph for you. We know the graph, actually it didn't look too bad. We know the graph looks like that. So yeah, with this method, you find your maximum and your minimum points, and when you don't know whether the graph kind of starts going down or starts going up, yeah, you find your maximum and minimum points, and you see which one's closest to your starting point. So yeah, find the first max, find the first minimum, and see which one's closest to your starting point, and that's which one it'll go to first, obviously. But that's just a way to think about it. Alright, so now we can just pretty much just chuck in all our points, because the question will likely want you to label the points to actually get marks. And we know all these points here. We know our 4 axis intercepts. We know the starting and end points. So we're just going to quickly write that in, and that's your question done. Well, I say quickly write it in, but who knows how quick this is going to be. So now our start point was 0, negative 2 square root 3, and our end point was 2 pi, negative 2 square root 3. We know our first minimum point was pi over 12, and then negative 2 minus square root 3. So pi over 12, it's too big. Pi over 12, negative 2, negative square root 3. And we'll just find our next minimum point while we're at it, which happened at negative 1, which was 13 pi over 12. Here, so we're going to go 13 pi over 12, negative 2, negative square root 3. And I'll just enter in my maximum points next. So we know our maximum points. We just kind of look for where the ones are before we translated it. So that'll be our first one here. So 7 pi and 12 is our first maximum point. So 7 pi and 12 will be negative square root 3 plus 2. And the next one, which would be 19 pi and 12. And then 2 minus square root 3. Because I'll look for the next maximum point that we translated across. Alrighty. Then we got just our x-intercepts left. which I'm not going to write this, I'm not going to write it in brackets and write it in zeros, but in your test, definitely make sure you do that just to be sure, to be honest. So we got our first axis-intercept, which will be, I think I might have actually missed an axis-intercept, the 0, 0. Yeah, I think we're going to want to include the 0, 0 axis-intercept. I'll actually quickly do that one, because it'll be pretty quick to do. So there was an x-axis intercept, because it's 0 inclusive. Our first axis intercept wasn't actually at pi 0, it was actually at 0, 0. So I need to actually quickly do that one here. That's actually just going to be pi over 3, and then negative. That's what I'm getting. 0, 0, it should be, that's what it claims it to be. That's actually impossible though. But, no. Alrighty. Realised I've done this whole question wrong. The points where x equals 0 no longer, in this first graph, the points where x equals 0 are no longer the points where x equals 0 on this new graph. So I knew there was something up with this question. I knew there was something to it. When you got your when you got your vertical translations, it changes where your like x-axis intercepts are, like just in total. So I'm pretty sure the only way to do that, so this one, was straight up just make y equals 0, and so yeah, solve it normally from there, because the translation method comes ineffective. I seriously just looked at my textbook and just grabbed the hardest looking one I could find, and then use this method on it. But now I've only just realized that method doesn't work for vertical translations. So you learn something new every day. I can tell you that much. Yeah, because why would an x-axis intercept be here? That's just telling us where points are in the center. That's straight up just telling us the center has moved from being at like what, y equals 0 to being at y equals negative 3. So it's pretty much just telling us all the points across there, which are 99% useless. So I'm gonna quickly go ahead and solve the x-intercepts to finish the question, because this is gonna be like an hour video. I swear, I don't even know how long it's gonna go for at this point. The video's a video though, so we can call it a day. Alrighty, to find your x-intercepts, we're just gonna use the normal method. Make y equal to 0. So then we just get square root 3 over 2 is equal to sine 2x minus 3. And because we know our domain, we want to solve for, obviously x is an element of 0 to pi. When you got a small period, you literally just go, oh look at this, the 2 is next to the x. Therefore 2x, we want to be an element of 0 to 4 pi. Just times the 2 onto whatever. Obviously 2 times 0 is 0, 2 times 4 pi. Sorry, 2 times 2 pi is 4, so we're going to be looking for solutions within 4 pi. And we know there's 4 solutions, so we can try to just look for the first 4 solutions we get. So yeah, so we actually wasted half our time over here. I was wondering why it was taking so long. I'm like, it doesn't seem right. So we wasted our whole time right there. But there you go. That's part of the process. Wasting time. You probably do it faster if you do it by yourself. Alrighty, let's get going. Therefore, we know that, 2x minus pi 3 is equal to, so we just take the sine inverse of both sides. So obviously sine inverse times sine is actually just, I think it's just 1. I don't actually know that, but let's just say it's 1. So then that cancels out, and we get that. So therefore we want to find when this is going to be equal to what? Square root of 2, this is pi over 3. So we got when 2x minus pi 3 is equal to pi 3. we want every time it's equal to square root 3 on 2, like we want all the times. So it's equal to pi on 3, want another positive 2 pi on 3, and you pretty much just swing around again, and you'll get 7 pi on 3, and you'll get 8 pi on 3. I think those are right. I really hope they are. Half this question's been completely ruined by me wasting half my time finding 4 axis intercepts and completely irrelevant. I even found another axis intercept. Well, thankfully I found the 0, 0, 1, realizing it doesn't get me to 0. So there you go, time wasters. So first we just have to divide all of them by 2. So we get 5 over 6, 2 pi on, because we only have 4 here because we're just looking for the first 4 that we know already. 2 pi on 6, 7 pi on 6, 8 pi on 6. I'm not even sure if I'm actually going to publish this video. I probably will, but I need to leave a heavy disclaimer that the video has the biggest time wasting thing you've ever seen in your life. So yeah, the reason we changed this here for our next step to find what x is equal to, change it to 2 pi over 6, which is just equal to pi over 3, but it's just going to be easier to add to these. So you got 2 pi on 6 plus pi on 6, that'll I think just give us pi over 2. And then this will give us 4 pi on 6, which will be 2 pi on 3. But then again, I really hope I'm doing this right. Who knows, could have already stuffed up. 9 pi on 6, that'll give us 3 pi on 2. Okay, these are looking really like a bit clean. And we've got 5 pi on 3. Alright, here's our pattern. Here's our pattern here. So, plus 2, plus 3. So on these we plus 3, on these we plus 2. We don't need to find any more though. So, and the pattern's probably irrelevant. So those are our x-axis intercepts. So if I can just get that to fit on the page, just x-axis intercepts for this domain. Pi over 2, I think these should be in order. 2 pi on 3, and then I got, 3 pi on 2, and then 5 pi on 3. Alright, there was our pattern here. From this 2 pi, because we know our period's pi, you plus pi onto this, and that'll get your next intercept. 2 pi on 3, you plus pi onto that, and that'll give you 5 pi on 3, and that's your next axis intercept. So there you go, that's your graph. I'm pretty sure now that we've made, well, we didn't really make any mistakes, we just wasted an insane amount of time. No mistakes here, we used the translation method, it gave us all the right points, but that's the takeaway. You when you see the graph with the vertical translation, know that to find your x-axis intercepts, you just use the normal method. There's no need to use this translation method. This is just really good for your maximum and minimum points, and also finding out which direction. Because after there's been a horizontal translation, especially, and it's in like a specific domain, you're not going to know whether it starts going downwards or starts going upwards, and this method also helps with that. But after wasting that much time, we finally got our answer here, which is, I really hope it's correct. I'm going to have to check that in a second before I upload it. And hopefully this video helped out. So, quick consolidation. You pretty much you got your graph, you find the translations, and then you sub in, from this normal sine graph, you sub in your max, minimum points, which you should know, because it's just like the basic sine graph. Sub in your maximum minimum points for a couple, and that'll give you your maximum and minimum points for your new graph. And then just remember, if it doesn't have this vertical translation, if that wasn't there, you can use this translation method to find the x-axis intercepts, which I'm still not even sure if it's faster or slower. It's probably slower, to be honest. And then, but if it's got this vertical translation, which obviously it does, we have to use a normal method. The normal method which I just did there to find it. That's it.